It's wintertime. That means it's time for me to catch up on some of the projects that I need to catch up on for my own stuff, including building some kits that I bought at Hamvention last year. Yeah, it's been like 9 months or maybe longer at this point in time that I've had these kits, and it's time to put them to work. One of these kits happens to be this. It's a common mode choke testing rig that you use with a nano VNA or any kind of VNA to test a common mode choke, as its name might imply. It's from Halibut Electronics. Keep in mind that I buy this stuff. I don't get any of this stuff for free or discounted or anything like that. It's just something that interests me because there's theory when you read it in a book that says, hey, if you put so many winds of, RG whatever around the coil this size, it will perform a choke. Well, theory's one. Let's be able to test theory with reality by building this thing. And then I do have some chokes that I have bought that I want to verify they actually work the way they're advertised. And there are a couple of chokes that I've built with ferrites that I also want to see that they work how they're supposed to work. Let's assemble this puppy and then take it for a spin. This being a simple kit, I didn't print out the inventory sheet. However, I do have it pulled up on my computer, and I can tell you that we're gonna run through the components to make sure that all the stuff is here. We have the main PCB, two sides, input side and output side, and the output side is labeled with the type of connectors they are, and the input side tells you the VNA goes on this side. One thing that I do like about the way this is set up is that it tells you, hey, on this side we're going to solder here, and on the other side, there's a socket goes here, and on the other side it's opposite. Solder here, socket here. In other words, since there's going to be SMAs on both sides, the instructions make it clear that even on the board, they make it clear that the actual socket goes here, and then for the opposite side, the socket goes there, and then you see where it says solder it over here. I like it like that. We have the board, we have 4 SMAs, females. We have 2 switches that are 2 position each, 2 BNC, 2 binding post, 2 SO239s, and 2 N-type connectors. And I hope one of these days that we actually move to this standard, but I'm not holding my breath. Keep in mind that this is version 3.0 Delta of this board, and that they have a newer version available. So if you get this kit now, the board is going to look slightly different. It's going to have slightly different components. He added more switches to the mix, but for my kit, I have everything I need. Now it's just a matter of assembling it, right? Let's move that out of the way. Oh, by the way, you do get a sticker. Instructions are on the QR code. I have my flux pen ready. Let's turn on the soldering iron here. So let's move some of the stuff out of the way here to make things easier. Start with the switches. They're actually pretty decent friction fit in there. This board is one huge heat sink, so I'm having to bump up the temperature on the soldering iron just to be able to get these pins done. Come on, warm up. Not the greatest Oh, that's fun. So the switches are tall. I should have checked that first. The switches are taller than the SO230 or the SMA socket. So they're standing it off, and that's going to be a fun way. So I'm going to have to hold this while I heat it. Oh, that's not going to be fun at all. How do I solve this? What's the difference in height? Not very much. Okay. Let me get a shim here. Oh, I need some... This shim is a little too tall, but hey, look, it'll work. And all I really need to do is get one done. Oh, this guy is skating all over the place. So one is done. Perfect. Better lucky than skilled. Solder one in. That'll hold it mechanically so that I can then get the others in. And since doing that to the center pin is easier, because I don't have to worry about spreading heat across the entire socket, I'm going to go with the center pin here. There you go. Hey, they're even flush. Got lucky on that one. The advantage of doing the shields, second also, is that once I heat one up, there's already some heat soaked to the rest, so getting the rest of them warm enough that the solder wets is a whole lot easier. Can't see the camera, so I don't know if you can see the temperature of the soldering iron, but it is set to 365 degrees Celsius. I don't know what that works out in freedom units, but if it matters to you, well, you know, now you know what it is in C, and you can do the conversion. There we go. Looks pretty good. Come on, heat up. And now, because my eyes are not good enough to figure out if I made a solder bridge there or not, I'm going to take my multimeter and do a continuity test. Very well. So it should be ground to ground. There we go. Nada. Oh, the switch has to be on. So it should be there to there. Yep. And then nothing to the center. And let's check the switch. So ground to ground. On to the center. To the other. No. So let's switch the other position of the switch to the other side. Then there to there. Nada. And then to there. Should be there. Yeah. We have the continuity we need here. Time to get the rest of the stuff done. May as well start with the other SMAs. Small to large is what they say in the instructions. And before the astute among you come along complaining about my soldering technique, never claimed to be an expert at this, I'm just an amateur. And with any luck, hell, look at that. They're even flush mounted. Yay! Time to get the grounds or shields on these. Ham radio ASMR. So my camera quit recording in the middle of that, but I have both of the SMA sides done. Now it's time to test and make sure that they are not bridged. So this should be shield to shield should work. Yeah. There we go. Or not. Oh, hang on. There, I have the switch in the wrong position, so let's go to through, and then it should be shield to shield should work. Yep, center to center should work. And then center to shield should not work. And then center to shield should not work. Awesome. Same thing on the other side. And now if I put them on through, I should be able to go center on the input side to shield on the output side. So input side is here. Okay. And then if I flip that switch, it shouldn't work. Awesome. There we go. The beeps, the extra beeps you hear are from me touching the shield as I move it around. And now we're in test mode. Okay, and then on through mode. Okay, let me get the BNCs done and we'll move on to the rest. I'm gonna speed through the rest of this. I'm gonna do the same thing with this, with the BNC, as I did with the SMA, and getting that was significantly easier to solder up than the SMA because the pin is obviously quite a bit larger. A little bit of flux on all the pins and on the board. Get a little bit of solder on the tip here. Let's give this a test. So we should be able to go center to center here. Actually, no, they're isolated, right? So, shield to shield, and nothing on the center. And for sake of, oh, that's still warm. Center to center, and nothing on the shield, and nothing on the shield. Okay, cool. So, center to shield, nothing there. And then, I am scaring myself with this soldering iron. It's so close to my finger there, so I'm going to move it out of the way. Awesome. So center to center is working, nothing to the shields. This is good. And then theoretically, we should be, since we're on the output side, we should be able to go center to center and have continuity, and then nothing there, and then center to center and have continuity, and then shield to shield on all of them. Yep, all of that works. Awesome. I'm going to do the rest of these connectors, and I'll come back when all of this is done. This is just basic assembly, okay? Now that you have the general idea, I'm going to do the same thing with the rest of it. So here we have it completely assembled. Things to note, these little tabs come with the banana clips. You don't use them. Don't worry about those. You can toss them up or throw them into the spare parts bits. That's part of the destructions already. The banana clips have 2 nuts apiece. Understand that this is a locking nut mechanism. So you tighten the first one snug, and after you get that one snug down, and keep in mind, this is just snug. This is a PCB. You don't want to go cranking on it, okay? Snug, maybe a quarter turn after that, after it's snug. Then, by the way, the banana plugs are 7 mil. The nuts for the SO239 and the type N's are 5.5 mil. In any case, once you have the primary tightened down, you come up behind with a second nut, snug it down, and then you make sure you're only engaging that, and you snug it down. And you'll see that, I don't know if you saw that, the primary stud actually completely spun around. This is not soldered down, doesn't have to be. All we're doing is giving a backup mechanical locking mechanism against the PCB. That way the primary nut can't back out. These are screwed through with the nut on the back end, and again, 5.5 mil, and you just snug them down. You don't want to crank on them either, because these will actually, the screw head will bite into this connector, and if you crank on it, you're going to either break the PCB or snap the screw. You don't want either one to happen, so you just snug it down and quarter turn after snug. You have the option of soldering in a wire from center pin to center pin here. Same thing here and here and here, so that you can put a 50 ohm standard on any of these. So you can do an open, a short, and a 50 on any of these for the sake of calibration. My standards are all SMA anyway, so I'm not going to bother to set those up. Those are optional if you have standards for SO239 or for type N. The BNC is already soldered through, so you can also use a BNC standard. Now that this is completely assembled, I've already verified the continuity that I need to have on all of this. Let's go put this on the bench. It's already on the bench. Let's put some stuff on it. Let's put a couple of chokes and test it out and see what we get. All right, so we have the VNA connected to the computer. The computer is running VNA Saver, and then we have the VNA connected to the input side of the common mode testing rig, and the switches are set to through. Right now they're set to through because even though I have a calibration already for the Nano VNA, I don't have it with these cables and this board in the line. So we're going to run a full calibration on it again in order that we are going to get accurate readings. Now, I also know that some of you are going to say, well, you know, you also need to test the leads and everything else in the calibration. I'm going to add one of the 2 leads that I'm going to use as calibration because I don't have a union in here. I don't have a joint anywhere. Otherwise, I would use both of the pigtails. I don't think this is going to matter enough that not having both of those in line is going to really, truly matter. So let's start on the computer and run a calibration. And run the calibration assistant. Please connect the short So in this case, we're looking at the standards that came with my Nano VNA. This is the open, this is the short, and this is the load. And we are testing on port number 1, which will be the one on the right. And I'm going to click on OK. Next we're going to do the open. By the way, I used a Sharpie on mine. S for short, O for open. And the actual load is a different color, so it's self-explanatory. I don't have to mark it. And then there's our load, all 50 ohms of it. If you wish to continue to perform 2-port calibration, which we want to do, yes. In this case, I'm going to get, and we're going to put a load on the second port here. And I don't have a second load handy, so we're just going to test that one. Please connect the through standard between port 0 and port 1. This case is where I'm going to use the jumper. So now we have a through. And because now I have a calibration, I want to save this. For the Nano VNA Saver, I changed the display so that all I'm showing is the S11 and S21 log mag, because that's what we're measuring with this rig. We're just going to measure how much the choke is choking out of the way. Let's run a scan on this device, right? So we're going to start with this choke right here. Again, we're just trying to see how well it does. Let's hit the, let's go back over to the computer. And as you can tell, I've already been playing, but let's run the sweep again just to get everything in there. Now, I'm not an expert on Nano VNAs. I don't pretend to be. You want an expert on that? The Smoking Ape has a killer amount of information on it. I'll put a card to his channel up in the description, and I'll put it down on the video description. But my understanding is that this line that we see here is the output, and then this line is what we're receiving back. And what we're seeing is at a minimum, at the beginning, 30 dB of rejection, and as the sweep keeps going, we get down into near negative 40 dB on 80 meters, at least 35 on 160 meters. And if we progress, we see that all the bands have rejection on them, at the very least of 30 dB until you get until 10 meters, and in 10 meters you're looking 20, call it 25 or so dB. Actually, if we go here, we should be able to see what the rejection is. There we go, negative 26 dB of rejection at the top of the 10 meter band for this choke. So I can trust this choke to get rid of common mode stuff for me now that I've given it a test. Let's disconnect it and put in line the ABR coax. Those are the two that I have handy. This and the ABR coax is all I have handy right now. I have one that I made with a ferrite, but I can't find it right now. Let's plug this puppy in. So this is ABR 316 and 5 ferrites. Let's run a sweep on it. And we see that it has an effect. It's nowhere as pronounced as that big choke, but then again, we're talking about just ferrites on the outside of the coax versus a very heavy-duty dedicated choke. Something to note is how smooth this rejection line is. The higher we go up in frequency, it's nice, progressive. The other one, the big one, obviously had kind of a jagged feel to it. It was it rejected more. So that's 5 ferrites. I do have this one here that's another 5 ferrites that I bought to put in line with between my 705 and the AH705. Let's add it in line here and see if 10 ferrites does better. If 5 is good, 10's got to be better, right? Let's run that sweep again. Oh yeah, That's a very noticeable difference. Look at that, just doubling the ferrites. It's almost a direct relation between, by doubling the ferrites, you double the rejection. Or it seems that way. That's a lovely, lovely graph to see. Now I'm wishing I could find my stupid homemade choke with using a ferrite, but I don't know where it's at. I looked for it. I can't find it. But that's really, really telling how well these inline ferrites do. And again, all this board is doing is switching the center pin to the shield so that we are able to test the ability of the shield to reject common mode instead of testing the interior, instead of testing the center pin of the coax or the center conductor of the coax. It's a nice little jig. I think I paid $60 for it. I can't remember, but I think it was $60. To me, worth it. Ooh, did you see that? Hang on, I touched the connector. Let me put this back in line here. By touching the connector, I'm changing the capacitance, and look at that. I'm shorting it just using my hands, and look at how much it does. Oh, this is really cool stuff. We're still doing negative 19 dB of rejection, which is really neat. Let's go of it, and we're back to negative 27 at, what frequency are we on? At 17.8 megahertz. This is neat stuff. There you have it, boys and girls. The kit's built. I was able to test 2 different types of chokes and then 2 of the same in line to see how much better they can do, and tip top, right? If you're looking for this, I'll put a link to Halibut Electronics down below. There's no affiliation on this one. It's just me buying stuff that interests me, that I think are useful to my shack. Hopefully you see utility to this and you might get yourself one, and if not, no big deal, right? We'll catch you guys on the next one. 7-3.